Hello, welcome to today's lesson, Understanding Codes in Data Transmission and Security. I am LG Tiliwagan, a faculty of the Department of Mathematics and Statistics of MSU IIT. When we talk about codes, data transmission, and security, then we are simply just talking about cryptography. Now, what is cryptography? Cryptography is a method of storing and transmitting data in a particular form so that only those for whom it is intended can read and process it. Cryptography is closely related to the disciplines of cryptology and cryptanalysis. While cryptography is the science or art of encrypting messages, cryptanalysis is the science or art of breaking those encrypted messages. And cryptology is just a study of these two. Cryptography includes techniques or ways to hide information in storage or transit. Cryptography is a very serious matter. In fact, during the World War II, the Germans used a lot of encryption for their top secret messages. Here is a picture of a German Lorenz cipher machine, which was used by the Germans to encrypt very high-level general staff messages. If you are a fanatic of war movies or detective movies involving Germans, then you might have encountered or heard about the Enigma machine. Yes, the Enigma machine was also used by the Germans and is the most popular in cinemas. But the Lorenz cipher machine was far more sophisticated than Enigma. As a matter of fact, it took until 1970s to declassify Enigma, and it took until 2002 to fully declassify the Lorenz cipher machine. Now let's go back in time to see the development of cryptography. Before the Common Era, the Spartans used the citale, while the Egyptians developed hieroglyphic writing and notable Roman ciphers such as the Caesar cipher. The picture shows a hieroglyphic writing by the Egyptians. Now, citales and Caesar cipher will be discussed later. Between 1 to 1799, Leon Battista Alberti invents polyalphabetic cipher, also known as the first mechanical cipher machine, which was considered to be a great improvement of the Caesar's cipher. Now, in Alberti's polyalphabetic cipher, as you can see in the picture, there are discs of different sizes, and on it are written the English alphabet together with some corresponding symbols. Between 1800 and 1899, the first long-distance telegraphic device was made by Joseph Henry, and Samuel Morse invented a telegraph system for sending messages using electricity. Again, if you have watched a lot of detective movies or war movies, then you could perhaps encountered or heard about the Morse code. Well, Morse codes are just messages that are sent by tapping out a special code for each letter in the form of short or long electrical signals. We have struck an iceberg. This is Titanic's final message sent via Morse code and was received by Olympic and other nearby ships. This was a very tragic incident that happened in the North Atlantic Ocean. While around 1,500 of the passengers of Titanic died, thanks to Morse code, around 700 were rescued. In 1900 to 1949, the first break of German Army Enigma by Marian Rejewski in Poland happened. In 1950 to 1999, Charles Bennett and Gilles Brassard designed the first quantum cryptography protocol, BB84. And in 2000 to present, Microsoft and its allies vowed to end full disclosure of security vulnerabilities by replacing it with responsible disclosure guidelines. Now let's go back to the Greeks' citale, which is a classic cryptography. The Greeks' idea on cryptography was to wrap a tape around a stick and then write the message under wound tape. When the tape was unwound, the writing would be meaningless. The receiver, of course, should have a stick of the same diameter and use it to decipher the message. Now let's go to cryptography in the digital modern world. As you can see, someone or this guy on the left is trying to send a message to this guy on the right. Of course, both of them uses gadgets. The guy on the left uses a MacBook or a laptop. Also, this guy on the right. And this guy on the right uses a tablet or an iPad. This guy on the left is sending a message over a cryptographically secure network. That's what these two guys hope, that this is a secure network. But unfortunately, there is an interesting fellow in the middle, which of course is trying to intercept the message that was sent over the network. Now, you don't want this guy in the middle to know your Facebook passwords or your email or your Twitter or Instagram or your ATM pins. Now, for those who are planning to be someone like this guy in the middle, then unfortunately, for your information, cybercrime in the Philippines is punishable by, of course, a payment of hundreds of thousands of pesos to millions and also imprisonment. So, if I were you, then just be like this two guys on the right and left, which appears to be CEOs of companies. Okay, let's discuss some terminologies here. Plain text. A plain text is just a message that is going to be transmitted or stored. Anyone can read the plain text. Encryption. It is the method by which we can hide the actual meaning of a plain text. Ciphertext. It is the result of encryption, which results in unreadable gibberish. Decryption. The method by which the original meaning of ciphertext can be recovered. Simply the process of converting ciphertext to plain text, and that is called decryption. Key. It is the secret piece of information which is used for encryption and decryption in cryptography. So those terminologies are summarized by this picture. We have a plain text, hello. We use the key to encrypt it, transform it into a ciphertext 75A01D97, and then the receiver used a key again to decrypt the message, transform it into plain text, and voila, you got hello. Now, there are two basic types of cryptographic systems. We have first the symmetric key system. Symmetric key systems require both the sender and the recipient to have the same key. This key is used by the sender to encrypt the data, and again by the recipient to decrypt the data. So this is how symmetric key system looks like. A plain text is sent by the sender, and then we used a secret key to encrypt it, transform it into a ciphertext, and use the same secret key to decrypt the message. And then the receiver then recovers the message. And a classic example of a symmetric key system is the Caesar cipher. The Caesar cipher, also known as the shift cipher, is one of the simplest forms of encryption. It is a substitution cipher where each letter in the original message, called the plain text, is replaced with a letter corresponding to a certain number of letters, up or down in the alphabet. For example, here is a Caesar cipher with shifting value 3. So as you can see, A now would be or would correspond to D, B to E, and C now corresponds to F, while D to G, E to H, and F to I, and so on until you reach X, which corresponds to A, Y to B, and Z to C. For example, the plain text that we're going to be sending is "We love discrete mathematics." And using the key in the previous slide, we have the cipher text. W becomes Z, E becomes H, and so on. And using the same key, we can decrypt the cipher text and turns it back to "We love discrete mathematics." Now here comes the problem of symmetric key system. If a hacker or someone would know the key for encryption, he can automatically decrypt the message. So here comes the asymmetric key system. Asymmetric cryptographic systems are considered much more flexible. Each user has both a public key and a private key. Messages are encrypted with one key and can be decrypted only by the other key. The public key can be published widely, while the private key is kept secret. If Alice wishes to send Bob a secret message, she finds and verifies Bob's public key, encrypts her message with it, and mails it off to Bob. When Bob gets the message, he uses his private key to decrypt it. Now here's a question. Can Alice decrypt the message that she encrypted? I'll give you 5 seconds to think. Thank you. The answer is no. Alice cannot decrypt the message. Only Bob can decrypt the encrypted message. On the other hand, if Bob wishes to send Alice a secret message, he should find the publicly available key of Alice, or Alice's public key, and then encrypts the message with it and then sends it to Alice. And then when Alice gets the message, she will use her private key to decrypt it. Similarly, Bob can never decrypt the message. In general, only the receiver can decrypt the message. Anyone can see the public key but not be able to decrypt the message. So here is an illustration of the asymmetric cipher key. You have a sender sending a plain text. We encrypt it using the recipient's public key, transform it into a cipher, and then decrypt it. The recipient would decrypt it using her or his private key into plain text. So as you can see, different keys are used to encrypt and decrypt message. If a hacker or an attacker would be able to get the key or have knowledge of the public key, they still cannot be able to decrypt the message. So more secure. So an example of asymmetric encryption is the RSA algorithm. And surprisingly, math is there. RSA derives its security from the computational difficulty of factoring large integers that are product of two large prime numbers. Multiplying two large primes is easy, but difficulty of determining the original numbers from the product, factoring, forms the basis of public key cryptography security. The time it takes to factor the product of two sufficiently large primes is considered to be beyond the capabilities of most attackers. Now, what are the uses of cryptography in the modern world? There are plenty. Well, I'll just enumerate 8 of them here. We've got ATM, email passwords, that's together with your Facebook passwords, Twitter or Instagram passwords, e-payment, e-commerce, electronic voting, defense services, securing data, and access control. Thank you for watching.